Alright, so here we are, 7.4b. Chapter 7 is rational expressions. 7.4 is adding or subtracting rational expressions, and here we are adding or subtracting rational expressions with different denominators. This is going to be probably arguably the most tricky section, I guess, only because there are a couple steps you got to remember. Because we're adding or subtracting rational expressions with different denominators, we have to convert each of those fractions, each of those rational expressions, to have the same denominator. So we've got to go through a couple different steps, but there are steps, I mean, those steps are the things that we've already gone through. So if you need to go through some of those, I guess, reminders about what some of those steps are, you can go back to previous videos. So here's what we're going to do. We're going to fast forward through all the slides that we've seen already in the handout. So we're going to go through adding and subtracting. That's the kind of the title page. This is things that we've done with adding and subtracting with like denominators. And now we're to the point where we are at adding or subtracting with different denominators. And here essentially are the steps of what we have to do to add or subtract with different denominators. So we've got to convert the fractions to a common denominator, because we can't add or subtract without having a common denominator. It's like 1/2 and 1/3. You can't add them, you can't subtract them. You got to have a common denominator. So this step, that step, that step, that step are essentially converting to a common denominator. So you got to factor each denominator. You got to find out what's missing in each denominator. And I guess in order to find that, you've got to find out what is the lowest common denominator. Lowest common denominator should include every single factor from every single denominator raised to the highest power. And then step number 3 says what's missing from each denominator. That will tell you what to multiply by. Multiply each fraction by the numerator, multiply the numerator and denominator of each of the fractions, each of the rational expressions, by what's missing in its denominator, and that will get you to a point where each fraction, each rational expression, will have the same denominator. And then you add or subtract. You write the result over the lowest common denominator, and then simplify if you need. So let's go through 2 examples. We're going to go through 2 examples, and then I'll leave you to your own devices to solve the third one. So here we've got 4 over 7k minus 3 over k squared. What we're going to do is we're going to say, we're going to look at it and say, if I'm subtracting, and the instructions say subtract, and I look and I say, there's a subtraction sign. If I look at that, I have to say, I've got to have the lowest common denominator. I have to have a common denominator in these 2 fractions. Right now I don't, so I say, for that one, I've got to factor it, and I say, well, there's a 7 and there's a k. And I also go to this one, this fraction, and I say, there's my green fraction. I've got to factor that, and I say, well, essentially that's a k squared. Normally we would write our factors here as 7k and k squared, but we really don't need to do that because it's straightforward enough. But we can go through our lowest common denominator, include every single factor from every single denominator, raise it to the highest power that we see it. So we've got to have a 7, we've got to have a k. So we've got to have a 7, we've got to have a k, and then over here the k says it's got to be k to the squared power. So there's our lowest common denominator equals 7k squared. So essentially down here, we're going to go down here and say, you know what, my target lowest common denominator should be 7k squared. Hang on a second. I don't know why this does this. All right. Lowest common denominator should be 7k squared. So we're going to write our common denominator target as 7k squared and 7k squared for both the blue and the green fractions. And then up here we're going to say, well, I'm going to put this down here as 4 over 7k, and I'm going to find out what I need to multiply by to get to my 7k squared. Right here, in other words, this is one of the previous steps, is what's missing from each denominator. Step 3 and step 4 is find out what's missing from each denominator and then multiply the numerator and denominator of the fraction by what's missing. So right here I'm going to say, well, I got 7k in my original denominator, and I got to have 7k squared, so that means I've got to already have a 7, and I've got a k, but I need a k squared, so I've got to multiply by k. And I've got to multiply my numerator and denominator by k over k. So now what do I have? I've got 4 times k is 4k 4k. 7k times k gives me 7k squared in my denominator. And now I've converted my blue fraction, 4 over 7k, to 4k over 7k squared. All right, so we've converted our blue fraction, given 4 over 7k multiplied by k over k, because k was missing in our 7k denominator, and we get 4k. 4 times k is 4k. 7k times k gives me 7k squared, and that's our lowest common denominator goal. So we've achieved our goal of converting our blue fraction into a blue and red fraction with our lowest common denominator. Now let's do the same thing with our 3 over k squared. We'll say that, well, I've got my original fraction is 3 over k squared, and I gotta say what's missing in my k squared denominator. That should be in my 7k squared target lowest common denominator. I've got to have a 7, so I'm going to multiply the green fraction by 7 over 7, because by multiplying by 7 over 7, we're essentially multiplying by 1, and by multiplying our k squared times 7, that gives us our target lowest common denominator of 7k squared. So then we multiply 3 times 7 to get 21. Sorry, green. To get 21. 3 times 7 is 21. K squared times 7 is 7k squared. And we've achieved our target lowest common denominator for the green fraction of 7k squared. 7k squared. And if you look at both the blue-red combination fraction and green-red combination fraction, we'll say that 4k over 7k squared gives us a 4 over 7k, which is an original fraction, the equivalent of the original blue fraction. And 21 over 7k squared is, the 21 cancels with the 7 to give me 3 over 1k squared, which is 3 over k squared, which is the equivalent of the green fraction that we started with. And now what we do is we just simply take our minus sign and we put it down here, and we say we're subtracting those fractions. And now we say now we've got essentially like fractions, or fractions with the same common denominator. We can just add or subtract as appropriate. We're subtracting here, so this answer would be 4k minus 21 over 7k squared, and that's a k. Yep. And right now I'm going to play devil's advocate, and I'm going to say, well, with this solution, can I cancel the k? Can I cancel the k with the k squared? Or can I cancel the 21 with the 7? The answer to both is no, because remember, we cancel factors, and factors are things that are multiplied together. These are subtracted from one another. 4k minus 21 tells me that this is not a factor, that is not a factor. And if you want to, you could say, well, this would be something, all that 4k minus 21 times 1. So one of the factors in my numerator would be all of 4k minus 21. That would be a factor that we could cancel with something down here, another 4k minus 21. But the k does not cancel with the k. The 21 does not cancel with the 7, and we're done. So I guess the next thing would be to say, from 4k minus 21, can we pull out a greatest common factor? 4 has 2's in it, 21 has 3 and 7, and we don't have a common factor that we can pull out, so therefore our answer has to be that one right there. And there's our answer. I'm going to leave this as it is, and we're going to go on to the next example in the next video.